Hello everyone, this is Sir John. In my previous video, I discussed to you about solving quadratic equation using quadratic formula. Today, I will discuss to you about the nature of roots of a quadratic equation. But before I start, please don't forget to subscribe to my YouTube channel and hit the notification bell to be updated of my upcoming videos. In this lesson, you will learn to describe the nature of the roots of a quadratic equation using the discriminant. Before that, we have to know and be familiar with the following terms: rational numbers, irrational numbers, perfect square numbers. A rational number is any number which can be expressed as a quotient of two integers p over q, where q is not equal to 0. Examples of rational numbers are 121, a whole number, because this can be expressed as a quotient of two integers by putting 1 to be its denominator. Negative 8. A negative integer is also a rational number because this can also be expressed as a quotient of two integers by using 1 to become its denominator. We have negative 8 over 1. A fraction 1/4 is a rational number. Another is a negative fraction. Negative 12 over 5 is a rational number. 6.5, a decimal, is also a rational number. This number can be expressed as a quotient of two integers, and that is equal to positive 13 over positive 2. Another is a square root of 25. Although it has a radical sign, but remember, the square root of 25 is equal to 5. An irrational number is a real number which cannot be expressed as a ratio of two integers. Examples of irrational numbers are the square root of 24. Unlike to the square root of 25, square root of 24 cannot be expressed as a ratio of two integers because it has no square root. Another example of irrational number is the square root of 12 over 2. Although this is written in fraction form, but remember, square root of 12 is not an integer. So this is an example of irrational number. A perfect square number is a number that can be expressed as a square of rational number. Examples of perfect square numbers are positive 4. 4 has a square root, and that is 2. So 4 is a perfect square number. Another is 36, which has a square root of 6. 81, 225, and 100. These are examples of perfect square numbers. In this lesson, you will also apply the skills you have learned in solving quadratic equations using quadratic formula. Remember the quadratic formula: x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where a should not be equal to 0. The expression b squared minus 4ac is what we called discriminant. We will use the discriminant to easily describe the nature of the roots of a quadratic equation. We will evaluate the expression b squared minus 4ac, or the discriminant, using the given values of a, b, and c, or the numerical coefficients of each term in the quadratic equation. The result of the discriminant can be 0, or it can be positive and perfect square. It can be positive but not perfect square, or it can be negative. Let's talk about the nature of the roots of a quadratic equation. When we say roots, these are the values of the variable that will satisfy the given equation, or simply, roots are the solutions of the equation. When b squared minus 4ac equals 0, then the roots are real numbers and are equal. Again, if the discriminant is equal to 0, the roots are real numbers and are equal. When b squared minus 4ac is greater than 0 and a perfect square, then the roots are rational numbers but are not equal. When b squared minus 4ac is greater than 0 but not a perfect square, then the roots are irrational numbers and are not equal. When b squared minus 4ac is less than 0, or the result is negative, then the equation has no real roots. Again, if the discriminant is equal to 0, the roots are real numbers and equal. If the discriminant is greater than 0, or we can say positive number, and a perfect square, which has square root, then we can say that the roots of the quadratic equation are rational numbers and are not equal. If the discriminant is greater than 0, but not a perfect square, the roots are irrational numbers and are not equal. If the discriminant is less than 0, or we have a negative result, then the quadratic equation has no real roots. Let's have example. 4x squared minus 4x plus 1 equals 0. Let's find the numerical coefficients a, b, and c. Make sure that the equation must be written first in standard form. So a is equal to 4, b is equal to negative 4, and c is equal to positive 1. Now, we will solve the discriminant of the equation. We will use the formula b squared minus 4ac. We will substitute the values. We have negative 4 squared minus 4 times our a is 4 times our c is positive 1. Then we will simplify. Negative 4 squared is equal to 16. Negative 4 times 4 times 1 is equal to negative 16. 16 minus 16 is equal to 0. So the discriminant is equal to 0. We can say that the roots are real numbers and are equal. The roots are real numbers and are equal. Another example, 2x squared plus 5x minus 3 equals 0. This equation is written in standard form, so we can easily identify the values of a, b, and c. A is equal to 2, b is equal to positive 5, and c is equal to negative 3. Again, we will use the formula b squared minus 4ac. By substitution, we have 5 squared minus 4 times our a is positive 2 times our c is negative 3. Then we will simplify. 5 squared is 25 minus 4 times 2 times negative 3 is equal to positive 24. 25 plus 24 is equal to 49. So the discriminant is equal to 49, which is greater than 0. And 49 is a perfect square number because it has square root, and that is 7. So we can say that the roots of this equation are rational numbers and are not equal. The roots are rational numbers and are not equal. Another example is 3x squared minus 6x plus 2 equals 0. This equation is written in standard form. So let's find the values of a, b, and c. A is equal to positive 3. B is equal to negative 6. And c is equal to positive 2. We will use again the formula in finding the discriminant. B squared minus 4ac. By substitution, we have negative 6 squared minus 4 times our a is positive 3 times our c positive 2. Negative 6 squared is equal to positive 36 minus 4 times 3 times 2 is equal to negative 24. 36 minus 24 is equal to 12. The discriminant is positive 12, which is greater than 0. But 12 is not a perfect square number. That means that the roots of this equation are irrational numbers and are not equal. The roots are irrational numbers and are not equal. How about this equation? X squared plus 4x plus 5 equals 0. This equation is already written in standard form. So let's find a, b, and c. A is equal to positive 1. B is equal to positive 4. And c is equal to positive 5. We will substitute these values to our formula b squared minus 4ac, the discriminant. So we have 4 squared minus 4 times our a, positive 1, times our c, positive 5. Positive 4 squared is equal to positive 16. Negative 4 times 1 times 5 is equal to negative 20. 16 minus 20 is equal to negative 4. So in this equation, the discriminant is negative 4, which is less than 0. If the discriminant is less than 0, then we can say that this quadratic equation has no real roots. The quadratic equation has no real roots. That's all about the nature of the roots of a quadratic equation. Again, we will use the discriminant to describe the nature of the roots of a given quadratic equation. I hope you learned from this presentation. Thank you for watching. Please don't forget to subscribe to my YouTube channel. Hit the notification bell for you to be updated of the upcoming videos. If you like this video, click like, put good comment, and share it to others. Until next time, goodbye everyone.